Newton is known for his 3 laws of motion, which explains how things move. Hello, grade 8 learner. I am Teacher Blis, your guide in this audio-video lesson. I hope you are ready to start with our topic, so please bring with you your answer sheets or activity sheets. Before we start, here is a learning competency you need to achieve at the end of our lesson. Investigate the relationship between the amount of force applied and the mass of the object to the amount of change in the object's motion. Do you play basketball or volleyball? Maybe you do, but if you don't, I hope you have seen or even hold it. You have observed that the ball moves once you push or pull it. This is called force. Consider a ball on top of a table as shown in figure 1. The ball will not move when there is no force applied to it. If you push the ball, it will move or roll across the surface of the table. And when it is again pushed in the direction of its motion, it moves faster and even farther. But when you push it on the other side instead, opposite to the direction of its motion, the ball may slow down and eventually stop. Lastly, when you push it in a direction different from its original direction of motion, the ball also changes in direction. In conclusion, force can make the ball or any object move faster, stop, or change in its direction of motion. But does this occur always? Can force always affect change in the state of motion of an object? To accurately describe the forces acting on an object, let us examine the figure, the effect of force of a ball. Let's take a look at figure 2, physical concepts illustrated on a ball. Figure 2 shows how force acts on a ball, but you need to be familiar with the following terms. Magnitude refers to the size of strength of the force. It is commonly expressed in Newton for meter kilogram second system, dyne for centimeter gram second system, and pounds for foot pound second system. In the international system units, Newton is commonly used, which is named after Sir Isaac Newton, an English physicist and mathematician. Next, direction. The direction of the arrowhead indicates the direction of the force. The length of the arrow represents the amount of force relative to magnitude. Point of application. The location where the force is applied. Line of action is the straight line passing through the point of application and is parallel to the direction of force. There are 2 types of force, namely contact force. Forces where objects touch or contact with each other. Examples of contact forces. Number 1, applied. A force given to a person or object by another person or object. Its symbol is F, depending on who or what applies force to the object. If a boy applies a force to a wall, we denote it with F boy. Refer to this figure. Number 2, friction. It is the force acting against or opposite an object in contact with which makes the movement of the object slow down. Friction always opposes the motion of an object. Its symbol is written like this. Air resistance, denoted by F air. is an example of frictional force of the air against a flying kite, airplanes, parachutes, or those in skydiving sports. For free-falling objects, this force is always considered negligible, meaning the magnitude is unnoticeable. Refer to Figure 4. The frictional force acts opposite the force applied. Number 3, normal. It is the force that acts perpendicular to the surface of the object in contact with. Its symbol is written like this. Please refer to Figure 5. Normal force acts perpendicular to the surface. Number 4, tension. It is the force applied to string, rope, chain, or cable. Its symbol is like this. Please refer to Figure 6, the tensional force or simply tension that acts on the rope of a hanging ball. Next, non-contact forces. Forces where objects do not touch or contact with each other. These forces act over a zone or area called field. Examples of non-contact forces. Number 1, gravitational. Is the force of attraction between two objects. In the case of the Earth, this gravitational force causes objects to fall down to the ground. It makes satellites and smaller objects stay in orbit near the more massive planets. Mass and distance of the two objects affect the gravitational force that holds them. The bigger the masses of the objects are, the bigger is the gravitational force between them. The closer the objects are, the greater is the gravitational force between them. The figure below illustrates gravitational force between the Earth and the Moon. Earth has bigger gravitational force over the Moon. The weight of an object, denoted by W, is an example of gravitational force of the Earth towards the object. In Figure 8, the weight of a book is illustrated. However, the weight of an object depends on the mass of the celestial body where the object is attracted to, meaning we seem to be lighter when we are on the Moon than on the Earth. Number 2, magnetic. Are forces exerted on a field of attraction or repulsion, as in the case of magnets and other magnetic materials. Magnets and magnetic materials have two poles, the north and the south poles. Attraction may occur when two poles are not the same, a positive and a negative, while repulsion takes place with the same poles, positive to positive and negative to negative. Please refer to Figure 9, opposite poles attracts. Balance forces. To describe a force, you must know two things. You must know the magnitude and the direction of the force. Suppose two teams are playing tug of war as shown in Figure 10. Each team is pulling with equal magnitude of force, FA and FB, on the rope but in opposite direction. Neither team can make the other team move. Forces that are equal in magnitude but opposite in direction are called balanced forces. Balanced forces do not cause a change in motion. When balanced forces act on an object at rest, the object will not move. Unbalanced forces. When you push a table and then it moves, unbalanced forces are present. Forces that cause a change in the motion of an object are unbalanced forces. Unbalanced forces are not equal and in opposite direction. Suppose that one of the teams in tug of war, as shown in figure 11, exerts greater magnitude of force FB on the ground than the other team. The forces applied on the ground would no longer be equal. One team would be able to pull the other team in the direction of the larger force. Net or resultant force. In an object, there may be several forces acting on it. Net force or resultant force is the sum of all forces acting on an object. Two or more forces in the same line of action exerted on an object are balanced if their effects cancel each other. When an object is at rest, a zero net force would make the object remains at rest. Moreover, when the object is moving, a zero net force would make the object maintain its velocity at a given time interval. On the other hand, when the net force is not zero, the object velocity will change. A net force exerted to an object at rest may cause the object to move. In a moving object, a net force will increase its velocity when the force is in the same direction of its motion. If the net force is in the opposite direction of the object's motion, the force will reduce the object's velocity. When the net force acts sideways on a moving object, the direction of the object's velocity changes. Now, before we end our lesson, you answer first the activities prepared for you. Try to do your best and your part in answering because I also did my part. Good luck!